Hello, this is Mr. Mac. This is the concept video for polynomial functions. Now, there's just a few things to cover here. So what we want to do is we want you to understand certain features of polynomial functions and their graphs. Now, the first thing I want you to know is that polynomial functions graphs are, and I said this in the last concept video, I'm going to emphasize it here, smooth curves. Okay, they go up and they turn and they go down and they go back up and they go back down and they back up, but they do not have sharp creases or bends in them. Small polynomial graphs are smooth curves. Now, on the one that I've drawn here, this point right here is considered an extrema. Notice, in its localized area, this is as high as that function is going to get. Now, we call this extrema a relative maximum, or many times we just abbreviate it to relative max, because there is no other x value in that immediate area where it will be higher. Now, a relative maximum occurs when a function has been increasing and then it stops increasing and starts decreasing. Even if later on it turns around and goes back up and maybe even goes higher, in this local area there is no point higher than that relative maximum. Now, we could say the same thing but in reverse for this point right here. This is also an extrema. It's referred to as a relative minimum, many times abbreviated just as a relative min. And once again, you'll notice that that's as low as the function is going to go in that local area. See, the function was decreasing, it stopped decreasing and started increasing. That makes this a relative minimum. Now, even if later the function turns around and goes down and maybe even lower, this, in that neighborhood there, that is a relative minimum. Now, anytime a graph turns, stops going one direction, starts going the other way, we call that a turning point. So we count turning points. Now, it turns out that the number of turning points in a polynomial function can never be more than one less than the degree of the polynomial. No guarantee it's going to have that many, but it can't have more than that. Now, the rest of the information is contained in, one other thing I do need to talk about is a thing that your author calls the location principle. And we've talked about this earlier in the year. If you have a graph of a function, and let's say at x equals 1, the function is at -2, so we have 1, -2, and then the polynomial function at 2 is at the point 2, 5, then what we know is that since polynomial functions are continuous, somewhere between 1 and 2 there was a 0. So if you have a polynomial function where the outputs change sign, then you know that there has to be a 0 somewhere between those two x's. Since y at 1 is -2 and y at 2 is 5 in this case, there has to be a 0 of the polynomial function somewhere between 1 and 2. And that locates, to some extent, where the zeros are. If you look at a chart of the output values of a function, wherever you see a change in sign of the y's, you know that those two x's contain a real 0. The graph crosses the x-axis. between those two x's. And that takes care of polynomial functions.